Hi there, this is Jacob Nash and this is a review of AP Statistics Unit 1. As you can see, I have very low battery and have lost my charger to this thing. So this video may or may not even be able to be made, but I'm going to try to make it very fast. But I'll still try to explain as much as I can. They made this app differently, so hopefully I can figure out how to use it. But anyways, the first thing that we're going to talk about... Okay, already I can't draw. Come on. Shouldn't this thing make you be able to draw? Draw with touch, okay. 5 number summary. So, if you're asked about a 5 number summary, what the heck is that thing? Well, it's a 5 number summary. And what are these 5 numbers? The first one is your minimum in the value, so the lowest number. The 5th one is the maximums. Easy enough, right? The middle ones are quartile 1, quartile 2, quartile 3. So what's quartile, in case you didn't know? Well, quartile 1 simply is when 25% of data is below. 25% of data is below. Simple enough. And a percentile, which we're going to talk about a little bit in a second, is just... So, like, if you said that your like ACT score was in the 25th percentile, which isn't that good, that means that 25% of data is below you, 75% is above. So you only did better than 25% of people, and that would mean that you're at quartile 1. Quartile 2 is if there's 50% below, which also means 50% above, and that also happens to be our median. So that's the same thing as the median. Then this is just 75% below, so that means 25% above. So 75th percentile, that means quartile 3. And obviously this one really means 0% below, and this one means 100% below. So that's simply what the 5 number summary is. How do you find that thing? Well, luckily you don't always have to do a calculation like you might think. You can type it into the calculator, and unfortunately I don't have a way to show you that on here, but I will tell you what buttons to push. So, Stat is the first button you push on your TI-84 graphing calculator. Then, if you haven't already made a list, hopefully you know how to do that, but you would push Edit, so you push Edit, right? And then you simply just type all your numbers into L1 that the data is. So then after that you push Stat again, and then you go over to the right and click Calc, and then you do 1 var stats, and hang on a second. 1 var stats, and then it should be there listed. So if you want a video specifically on that, please comment below. So that's 5 number summary. All right, the next thing we're going to talk about is interquartile range, IQR. What's that thing? It is simply quartile 3 minus quartile 1. I already told you what those mean. This is if there's 75% below, and this is 25% below. Now, you do have a formula sheet, but unfortunately, some things you just have to know, which includes this. It is not on the formula sheet. So you need to know that. Now, outliers. Let's talk about that next. Outliers. What do you think those are? You might have heard it's something that's like out of the ordinary. So if you have like a linear graph, you see something over there, or I guess I should say scatter plot, you see something over there, then you're like, oh, that's an outlier. Well, in statistics, we kind of have to calculate that. We can't just say that we think something's an outlier, because it might not be. How do you find that thing? Well, basically, there's an upper and lower limit. So see what I mean. So lower limit, so I'll just say LL. To find the lower limit, you do quartile 1 minus 1.5 times the interquartile range, and which is this. Then, to find the upper limit, you do quartile 3 plus 1.5 times interquartile range. So let's say this turned out to be 7, this turned out to be 9. Well, that means any number that's not 7 through 9, so if 6 or 11 or something, that's an outlier. So that is how you find outliers. Also, you have to know these equations. So pretty much you need to memorize these things. If only there was a way to X out all of this, but I don't think there is, so sorry. Oh, I'm still on 9%, so maybe I will be able to finish the video. And then I still have to upload it to YouTube, though. Huh. Alright, so let's continue. The next thing you need to know is about skew. Skew, Skew is just if there's something in the data that makes it a little bit abnormal. It can make the mean go crazy, and here's what I mean. Let's say you have a bunch of like scores right here or something, and then you're like, oh, all the way over there. What the heck? That's skewed. And how do you find a skew in a bar graph? Well, there's skewed left and there's skewed right. You might think since all the data is on the left, that's skewed left. That's easy to mix up. But since it's always where the abnormal thing is. The abnormal thing's to the right, so this is skewed right. Because it brings things like the mean slightly to the right. Another way that you can think about it is if you just draw like a curve down. Okay, imagine like a skateboard on that thing. Where's that going to go? That's terrible skateboard, sorry. It's going to go to the right. It's going down the hill. That's another way you can think about it. So this would be skewed right. This would be skewed left. So right, left. This would be pretty much symmetric. And we never can say it is symmetric. We can say it's almost symmetric, relatively symmetric, because that's not really correct. Now, there's not just this. There's not only bar graphs, or histograms, I should say, that can be skewed. There's other kinds. We know that there's also stem and leaf. So that's where you have something like 1, 2, 3, 4, 5. Say 1. I don't know. It's taking me a long time to make up these numbers. 2, 1, 0. Okay, what about this thing? Is it skewed left or skewed right? Well, all you have to do is turn this thing over and make it like it's a histogram. So whew, we're turning that thing over. Now it's like this. All right, well, let's draw our thing. Oh, it's going to go to the right. So that means it's skewed right. And if more of the numbers were like over here, then it would be skewed left. All right, but there's not just that. There's also that thing called a box plot. Remember that thing? So for the box plot, it's easier than you might think to figure out if something's skewed left or right. You just look in the box. The line in the middle is the median. We're going to talk more about that. But whatever rectangle's bigger tells you what skew it is. So it's skewed right because the bigger rectangle's on the right. Well, what about if it was like this? That means that then it's skewed left. It doesn't necessarily tell you if it's skewed left or right based on like if this whole thing is shifted left or right. We're talking about where the median is. All right, so speaking of, let's talk about box plots now. So box plots. The point of this thing, this box plot, is literally it tells you the 5-number summary. So here's what I mean. This is the minimum. This is quartile 1. This is quartile 2, wherever the line is. This edge is quartile 3, and this is the maximum. So that means this is really the median. That's literally what this thing is. So that also means that this full thing is the interquartile range. And there you go. That's how you can tell what a box plot's saying. It doesn't matter if the box plot goes up or down. That doesn't matter. All right. Now we're going to talk about how we can describe data and compare data. It's not enough to just know what something is. We need to be able to compare, and we can compare with something called SOCS. I didn't come up with this thing, credit to whoever did, but that stands for shape, outliers, center, and spread. What do these four things mean? The shape is literally, is it symmetric or skewed? If you think it looks symmetric, don't say that it is. Say that it's almost, or relatively, unless you know for sure that it is. We already talked about how to know which way it's skewed. Outliers, I already said how to find those. The center can be the mean or the median. You almost always are going to use median as the center. Why? Well, the mean is impacted by extreme scores, so that outliers basically. So imagine you get a whole bunch of good test grades and you're absent and your teacher puts a 0 in the grade book. That's going to bring your grade down. What is your grade? It's the mean. So that's what I'm saying. But think about it, the median, the middle number of your score. So let's say your scores were like 97, 98, 99, 100. Those are what scores you got on tests. You got a 0 in the gradebook. Well, the original median would be 98.5. But now it's 98. Didn't change that much, did it? But the mean is. So that's why if we have something that is ever skewed, which means usually that there could be some kind of potential outlier, then we're going to use median. We would only use mean if it was symmetric, which is rarely the case. So median is probably what you're going to want to go with. The spread is simply the range and standard deviation. I already made a video about this, so I hope that you know what those things are. Alright, so that's SOCS. We always want to use those four things if you have an FRQ in which you have to compare data. You talk about it. You don't just say the standard deviation is this. You say the standard deviation of something is higher than something else. Alright, mode. Hopefully we know that's what appears the most. Well, there can be different kinds. So this is unimodal. There's only one mode. This is bimodal. There's two modes. This is multimodal because there's more than two. And then this is just uniform, like, what the heck? It's all the same. Pretty simple. All right, that's mode. All right, let's move on to the next thing. All right, the next thing is we're going to talk about quantitative versus qualitative data. Qualitative is also called categorical in here, so really that's just what I'll say. Categorical, quantitative. So categorical is just things that are just, it doesn't necessarily mean things that are not numbers, because they can be numbers. If you have something like a driver's license number, or maybe gender. See, obviously that's words. Anything that's a word is categorical, but also numbers can be. What grade you're in. So if you're in 10th grade, 12th grade, whatever, that's not quantitative, sorry. It's not quantitative because that just doesn't tell us anything. That's just kind of a random number. Zip code, same thing, categorical. Quantitative is something that's actually data of something, some measurement of something. So that's something that's important to know. All right, we're not done yet, sorry. And I still have some questions that I think it's good for us to do. All right, an association is a relationship. Just so you know. All right, we're going to talk about now a standardized score. This is also known as a z-score. All right? This is basically something in which you can compare two data sets. So, for example, the ACT and the SAT, they're scored differently, aren't they? One of them you can get up to a 1600. One of them you can get up to a 36 as of today. But anyways, you know, like, what if you got like a 31 on one and you got like a 1450 on Another one, you might want to know which is better. That's a z-score. A z-score is how many SDs, how many standard deviations below or above the mean. And once again, if you don't know what a standard deviation is, please watch my video about that. So there's a formula for the z-score, which I don't think is on your formula sheet. I don't believe that it is, so you would want to memorize this. Z-score is x minus mu divided by sigma. What does that mean? X is just whatever data point you got. So like I said, 31 or 1450 if you're trying to compare. That's the mean. That's the standard deviation. That's simply what a z-score does. Right? So then, now we're going to talk about transforming data. What does that mean? Transforming data is literally just if you do something to the data all the same. You multiply every data point by something, you add something to every data point, that's the same thing, whatever the case may be. And we have to know what things change and what things do not. So let's talk about if you add or subtract something to all the data. So let's say our data is 2, 4, and 5. Randomly, for some reason, we just decide to add 1 to all of them or subtract something from all of them, whatever the case may be. All right. Our shape is going to be the same. Think about it. Everything. If you added 1 to everything, it would just shift to the right. Same shape. Now, the outliers are going to be different. Obviously, the points change, so it would be different. The center is going to be different too. The median might change by the slightest bit or a bigger bit depending on what happened, but the mean will definitely change. And then this, but the standard deviation and range is actually going to be the same. Think about it. If your minimum and maximum value were 2 and 5, the range is 3. You add 1, all right, now we're at this. Well, still, the range is 3. Same thing with standard deviation. So you need to know that if you add or subtract something to all of them, it's not going to change the range. It's not going to change the standard deviation. It is going to change the mean and median. All right, what about if we multiply or divide something? Well, that's actually going to change everything. Everything. So, that's transforming data. That's all you need to know. You just need to know what would happen in a hypothetical situation, because you could get a question like that. All right. Density curves. Density curves, there's different ones, but the one that we're going to talk about is a normal curve. So you just need to know the normal curve is a type of density curve. And what the normal curve is the same thing as the bell curve. And we can look at a lot of different things with this thing. Bell curve is basically just what is expected to be the normal type of thing. So, type of thing. Okay, I need to be more specific, right? Here's what I mean. I mean that it's expected that the scores that people commonly get on standardized tests, for example, should look in a curve like this. Like, there's not that many people that get super high scores. There's not that many people that get super low scores. Most of them get about the same. So, the middle, the highest point, or the middle right here, that is the mean. Now, this distance right here is one standard deviation. And so, basically, one standard... There's something called the empirical rule that you need to know. Empirical rule is also known as the 68, 95, 99.7 rule, which is that 68% falls within 1 standard deviation of the mean. 95 is 2, and 99.7 is 3. So here's what I mean. If the standard deviation was 2 and the mean was 3, well, that means that 68% should fall in between 1 and 5, because that subtracts 2 and 2. Oh, that probably wasn't a good example, because then we're going to get into the negatives. But hopefully you know what I mean. If the standard deviation is 2, falling within 1 standard deviation would be 1 to 5. So 68% would be 1 to 5. That's what we can see with a normal curve, right? And there's ways that we can do things like this, like percentiles into the calculator, and I'm going to talk about that in a second. All right. So next, we're going to talk about standard normal distribution. I'll just say dist for now. Standard normal distribution. This is if the mean is 0 and the standard deviation is 1. That's what this means. Why? What's the point of this? Well, it is a form of transforming data, because we're kind of shifting things to a point that we can use for different data sets, if that makes sense. And there's some kind of notation that we can use, which is n mean standard deviation, or sorry, comma is what I was trying to do. So if you saw something that was this, that would mean that the mean is 0, standard deviation is 1. If you saw something that was like this, mean is 3, standard deviation is 5. Right? So that's what that means. Now we're going to talk about something else. I hate this stupid thing. It takes so long to erase. All right, good enough. All right, so now we're going to talk about percentile. Percentile. That is percent below or at. Below or at. So that really means this. Less than or equal to. That's what a percentile means. And what's the point? Well, you might need to know, you might be asked, find a percent at or below. Well, what you have to do, you have to enter your data, like I already said, and then you need to make sure that your stat wizard is off. So push mode and stat wizard. Then you would push second and then vars. Then push normal CDF. Make sure it's CDF. And then you're going to get something that's kind of looks like this, which we just talked about. And you're going to enter, it's not the same thing though. It's gonna have parentheses, sort of like what we just saw as the notation, but that's not asking you the mean and standard deviation. It is asking you to do either of these three things, depending on what kind of question you're asked. If you're asked to find percent below or the percentile, you're going to do the minimum, type in the minimum, and then type in the z-score of whatever you have. The z-score, not the point itself. So if it's saying, how many students scored below a 26? Do not type in 26. Type in the z-score for 26. Then, if you're trying to find percent above, then you would do the z-score as the first thing, and then the maximum. If you're trying to find the percent in between, so how many scored in between 26 and 28, you do the z-scores of both. And then literally, whatever your answer is going to be the percent in decimal form. And sometimes if we don't have a minimum or maximum, we can use negative 99 or positive 99. Just letting you know. All right? So, like I said, always put the z-scores in, not the points. All right. Now, you might have to do it reversed. I just showed you how to go from a z-score to finding the percent. But if you had to do it the other way, percent to z, do second vars, then inv norm, and then you enter the percent. Of course, you have to have the data in, so you'll have to put the data in first. But you enter the percent below. Pay attention to what I'm saying. You enter the percent below, not the percent above. So if you're saying, like if it's saying what's the z-score of something like certain percent above, well, you have to do 100 minus whatever that percent is that you're given, because it has to be percent below. This makes it percent below. And yeah, we're not done yet. I realized I'm just gonna make a separate video of doing the questions, because I know I don't have enough battery for that. Now we're gonna talk about a Z table. It's not really the specific name for it. Really, they call it standard normal probabilities. This is on your formula sheet. So if you see something that has like a table with crazy numbers, that's what I'm talking about. There's two parts. There's a part when it's negative, and there's a part when it's positive. Depending on what z-score you get and the probability that you're trying to find, that will tell you what page you use, the positives or negatives. So it's going to be like this. We have z right here, and there's, let's say that a z-score is maybe negative 1.47. So you would find on right here where it says negative 1.4. Okay, I found that. And then over here, so that's that part. So this part goes right here. Now this part that's in the hundredths place, that's going to be over here. You're going to find something that says this. Then you're going to go down and find where they intersect. And this is going to be, there's going to be some kind of number here. And look at that. That means that we're going to have to change that to a percent. So what would that be? That would be 7.08%. That's whatever that given thing could happen. But that is something you have to take note of, is that that's the chance that something is less than whatever you were given. So it would make more sense when we got a question, and we're going to have one, so please watch the next video. But that's less than. That's what the table shows. It shows you that the percent that something would be less than whatever value that this z-score was of. So I'm going to say that again. The percent that something, whatever the scenario might be, is less than the point that this z-score was of. Now, if you want to know the percent that it would be greater than, then you would have to do 100 minus 7.08. That's the z tables. Any day now, I'll finish erasing this, okay? All right. Now, we got only a couple more things, which is, all right, central limit theorem. Central limit theorem. What the heck is this? This is just something that you just have to know and what it states. And it's kind of talking about when we assume things for a normal distribution. It's assuming that something must be large. So you might want to write these four things down. Sample is large. Mean is normally distributed. That's like what we already showed. And then it also assumes that samples it's very hard for me to write with this thing. I'm sorry. Samples are independent. This is the struggles of being left-handed in technology. Because my hand has to be up when it's normally down when I write. They are independent of each other. Other thing is, as the standard deviation goes down, the standard deviation goes down as sample size goes up. So sample size increases, standard deviation goes down. This is the central limit theorem. We just have one more thing to go over, which is something that I forgot to say, which is talking about a negative or positive skew for box plots. So remember, the skew is always to where the thing that's abnormal is. So let's say that we have an outlier right there. This is a positive skew because the thing is at a higher value that's making it skewed. But if instead it was the opposite, this would be negative skewed. See? So this is positive, this is negative skewed. And that's all I have for you. Please watch the next video of me going